Good morning, everyone. Thank you for joining us in this fairly early morning session on MATLAB. My name is Sumit. I'm a customer success engineer / application engineer at Mathworks. To tell you a little bit about myself, I have a background in electrical engineering, bachelor's and master's with a background in image processing, computer vision, data analytics, high performance computing, and so on. I have been a user of MATLAB for about 15 years, and I have been at Mathworks for about 11 of those, working with users of MATLAB in academia and the industry, and helping them use the products in the most effective fashion. So this morning I will be talking about data analytics and machine learning with MATLAB. And my goal here is to give you a high-level introduction to some of the capabilities we have in MATLAB for analyzing big data, developing mathematical and machine learning models, and then using them for prediction purposes, as well as an overview of some of the capabilities we have in terms of parallel and distributed computing, as well as sharing the applications and your work with other people in different forms. I know this is a lot to cover during the session. So what I'll do is I will make sure that I send you all the files that I'm using so you can take a look at it at your own pace later on. And I'll also point you to some resources that you can refer to in future as well. And of course, you have access to Mathworks directly. If you have any questions, feel free to reach out to us too. So the first thing is I wanted to kind of cover a little bit as to why MATLAB as a tool of choice for your work. Over the last few decades, we have been working on making MATLAB as productive and as easy to use as possible for engineering and scientific applications. And we're trying to make sure that you focus on your work as opposed to spending time working on other things. We provide a lot of ready-to-use capabilities through different types of toolboxes. We'll see some of those in action. We have capabilities that allow you to take your application and run it in a production environment without making too much changes to your application or to your code. It is, of course, reliable. It has been used for really large-scale applications and missions across different industries. And over the last few years, as technology has been improving, and we are starting to work with larger amounts of data, and as better hardware has become available, our products have kept up with the trends as well, with options to work with GPUs, clusters, and clouds, computing environments, and so on. So we'll see some of these things in action in the next hour or so. I'm going to assume for this talk that you have experience with MATLAB. I will not be showing specific features or how to get started with MATLAB. But if you're new to MATLAB, or if you need a refresher, I would like to point out these couple of free trainings that we have available on our website. We have MATLAB On-Ramp, which is a free 2-hour tutorial, interactive tutorial on MATLAB, and we also have a new deep learning on-ramp which talks about how you can do deep learning with MATLAB and get started with that. So I'll encourage you to take advantage of these resources. Now, before I get into showing you a demo and then showing you a MATLAB in action, just wanted to talk a little bit about the data analytics or machine learning workflow at a high level so that we are on the same page. Now, the first thing we need for any workflow like this is data itself. And data can come from different sources. It can come from different types of files, like text files, image files, signals files. It can come from databases, or it can even come from sensors. We live in a highly connected society right now, and with access to lots of low-cost hardware, which of course has sensors. So we might be getting data from those sensors that we can use for making informed decisions. Now, once we get hold of the data, typically the data is not in a ready-to-use form. If it is, then we are very lucky. If not, we have to work on the data. We need to clean up the data. We need to transform the data, or kind of reduce the data to extract only the most important, say the data that we need for our application. or we might even try to go at a higher level and try to extract features from the data that can be useful for our application. Now, once we have processed the data, that's when you get into the exciting part of developing predictive models or mathematical models that can be used for extracting useful information and predicting the future in some ways based on the historical data. So we create machine learning models. We do things like parameter optimization if we are fine-tuning a system, and so on. And so a lot of these things can be done at different scales, but typically for large-scale applications, this is the point when you start thinking about scaling up as well. And scaling up can mean different kind of things. It can mean scaling up to Hadoop Spark-enabled clusters. It could mean things like taking advantage of like GPUs or additional processing powers or multiple core machines or clusters, and so on, all with the goal of using more data and come up with maybe a more refined model that can help with the application and prediction purposes better. And finally, a typical fifth step is deploying this whole application or this whole model that we have developed in different forms. And some of the forms it can take is we could deploy it as desktop applications or web applications or integration with embedded systems. So once you have developed an algorithm, you might want to deploy it to a low-cost hardware or a GPU or an embedded system, which can be, say, put inside a car, for example, for if you're working with autonomous driving systems. So with this in mind, let's take a look at how MATLAB can help you do these things with the help of an example. Now, for today, I picked up an example that deals with predicting damage costs of weather events. With climate change happening, I thought this might be, and all the discussions around that going on all over the world, thought this might be an interesting example to take a look at. So what I have is I have historical data for weather events from 1980 to 2017 and lots of Excel files. I'll show you an Excel file. And what I want to do is I want to pre-process the data and then develop a prediction model that can predict the amount of damage or amount of cost it can incur based on the type of the event, the location of the event, the time, month, or year of when that event happens, and so on. And basically, the goal is to be ready for the future if needed, like make budgetary allowances and so on. To show you kind of a starting point and where we want to end up with, I'll just show you a sample file. So this is the type of data I'm working with. So this is the weather events record from the year 2017, and you can see there's lots of data here in terms of the year, when did the event happen, when did it begin, when did it end. We have things like event IDs, where did the event happen, the location, and the type of the event, and then the city and so on. And we have other information like how much property damage was there, how much crop damage was there, and we also have some other information like narratives and so on, that how it was being reported in the media and so on. So this is a pretty comprehensive type of weather events details or reports that you can actually download from the website of government agencies. So I want to download data like this, and I want to come up with an application like this, which is an interactive application in which I can select the type of a weather event. For example, if I want to look at tornadoes that might have happened in the state of Texas, and I can select, let's say, something might be happening in the month of, say, July, let's say 12th July, and I can set maybe the duration to see how big how long the event was, and get a sense of how much damage an event like that might cost. And then by using this number, I can budget for a future event like this. In between, I've also developed a MATLAB script which captures my entire analysis process, and that I can use, that I can share with other people, and I can take a deeper dive into the analysis itself. So with this, I'm going to take a deep dive into how you can do the whole thing, create a mathematical model and an app like this in MATLAB. And please feel free to share your questions in the chat window, and I will try to address as many of them as possible at the end. So let's get started here. Now, as I mentioned, I'm assuming that you have experience with MATLAB, but I'll point out a few things here. So I'm actually going to mostly stay in MATLAB for this entire application, or this entire discussion, and I will just step through this live script which captures the analysis. In case you're not familiar, live scripts in MATLAB allow you to capture your entire application narrative. So you can see, you can include formatted text, you can just include table of contents, you can include images and text and graphics, you can include MATLAB code, as well as the output of the code shows up inlined as well. So I'll use the script to step through the analysis process. Now, coming to our application, we need to develop a mathematical model that can predict damage cost from weather events. There are different approaches you can actually take to develop a mathematical model like that. Examples in curve fitting, or you can take an approach of classification, regression. You can use neural networks or deep learning techniques, system identification. You can even use econometric techniques to develop a model like that. In this particular example, I have actually taken advantage of regression techniques, but you're more than welcome to explore the other techniques. All of these are supported in MATLAB. So the first step was of the data analysis process is to actually get a hold of the data and then clean it up before I can actually develop a mathematical model. So I have another script here called Preprocessing Data, in which I have captured the pre-processing steps. And I'll step through this real quick and highlight some of the key things here. One thing I will start by pointing out is that this is a typical large data application, or I would say medium-sized data application. I have data for like about 20 years in one directory, and it's about 1 GB in size. This is the same workflow can apply for data of a much larger size as well. But 1 GB is still large enough that I do not want to load the entire data set in the memory at once. So I'd like to point out that we have a lot of new capabilities in MATLAB to work with large amount of data, and one of them is data store. So data stores, if you're not familiar, allow you to basically create a handle into the folder in which you have all your files, and as and when data is required for processing purposes, the correct amount of data is loaded into the memory, into the main memory from the disk directly. That way, you don't have to load the entire data and choke up the RAM. So if you can see in the storm data folder, I have all these files, but I just create a data store and point to the folder, and the data store automatically identifies all the files that are available in that folder and helps me work with them at a high level. Um, it is very powerful in terms of being able to selectively export files, export data from files, and identify files, and so on as well. So in this particular section, I'm just in the first part of the analysis, I'm actually just developing a pre-processing algorithms for data from 2017. So that's how I can select the files for 2017 and get a quick preview of what the data looks like using the preview method of the data stores. And to actually do a decent amount of pre-processing, I'm actually going to read in about 50,000 rows and then process the data. Let me just zoom out a little bit so I can see a little bit more of the file here. So pre-processing can be done, can mean a lot of things and can be done in a lot of different ways. We have high-level functions available which allow you to do things like smoothing of data, find and replace missing data, or delete missing data, and those kind of things. In this particular case, the data that we have is not really in a time table format. Even though it is a time sequence data, in some ways it is not properly organized. So I can use high-level commands to convert that to timetable format. So I have some sequential data, and then do some quick sorting here. And based on the analysis approach I took, I wanted to keep the focus on the location and the type of the event and so on, and also the amount of damage that was being caused by the events. So I can use high-level commands like reorder variables in order to and then a little bit of commands to reorder the data. One of the other important things we're looking at was duration. So MATLAB now has capabilities to handle time data very effectively and efficiently. So I can calculate from the timestamp, I can quickly calculate the duration of an event. And as you can see from this histogram, that most of the weather events that happen are actually quite short in duration, but there are some of them which can be actually quite long, and which we can treat as outliers, or we can come up with a special way of handling those events. So now another thing I did here was to remove some of the missing data by using the rmmissing command. So depending on how you want to process it, you may want to remove the missing data, or data with missing rows with some of the missing data, or you may want to take advanced approaches as well. Now, as the data was being reported, it was being reported in a lot of different types of categories, like thunderstorms and winds and high winds and so on. In order to simplify the processing a little bit, what I did was I took advantage of categorical arrays in MATLAB. So this is a new data type in MATLAB as well, which allows me to, in this particular case, merge the categories of data. That helps me reduce the dimensionality of the data and makes it easier to process. The other one of the major advantages of working with categorical arrays is categorical arrays are actually very highly memory efficient. So for example, the categories here are, we are looking at those as text like wind and high wind and so on. But in the background, they're not being stored as text. They're being stored, they're being mapped to numerical values, which allows for really efficient storage. So here's some more processing here in terms of string handling as well. For example, the original data that we received, the damage was actually being reported as strings as opposed to numerical values and dollar amounts. So this is where I am actually converting the strings to numbers and processing the strings. I will not go into the details here. I will let you take a look at it. And While I'm doing all this, it's also a good idea to keep an eye on overall, are we going in the right direction or not? So we have created a very rich set of visualizations that can allow you to explore your data, and while you're processing it, so you can start getting a sense of the direction you want to move in when you get into developing a mathematical model and so on. So in this particular case, try to zoom out a little bit. You can see we have this heat map which talks about the damage cost across different locations for different types of storm events. And as we can see that the black spots are actually actual data, while the gray box is actually missing data. So first of all, we can see there's a lot of missing data that we have, which can happen due to various reasons. Either it was not recorded, or it was not recorded, or things like that. Also, we can see that hurricanes here, for example, there are two white spots here, which mean a lot of damage, which happened in 2017. So one of them happened in Florida, and the other happened in Texas. So this is how we can build intuition about the model or the data, and then get a sense of where we want to go. A few other visualizations I'll quickly point out that we have. We have this capability to visualize graphs to get a sense of connection between event types. For example, in this particular case, blizzards are related to storms, winter storms, and snow, and so on. So if you want to visualize based on geography and the type of events, you can use some of the capabilities from the mapping toolbox, like the GeoBubble plot, and so on. If you want to take a kind of a deep learning approach and you want to analyze text, you can start with something like a word cloud to get a sense of how are things being reported, and then you can easily convert the text information to something that is more amenable to machine learning or deep learning algorithms, to the text analytics toolbox as well. So far, all the analysis about the exploration or cleanup of the data I did was for a particular year. So from here on, I wanted to take a look at aggregate the data from all the years to start developing the mathematical model. And the way to do that in MATLAB is, so we already created a data store that actually points to all the files we have, all the data that we have, and then the next step of doing processing the data is actually taking advantage of two things. One of them being tall arrays. So tall arrays are a new type of data type in MATLAB, which was released about 2 years ago, and it allows you to work with tall data. Basically, it means you have a limited number of columns, but you have millions or billions of rows of data, and it's highly efficient. When you're performing calculations, it will allow you to load only the requisite amount of data in the memory as and when needed, and it is very smart in terms of kind of batching up the calculations as well, so that to minimize disk access and speed things up. On speeding things up, tall arrays and data stores and these operations, they work through, they can take advantage of parallel computing capabilities in MATLAB as well, using parallel computing toolbox. And I'll discuss a little bit more about parallel computing toolbox later on. But I just want to give you a sense of how I did the pre-processing of the data. As I mentioned, I'll give you the files. You can take a look at it, play with it at your own pace, and then let me know if you have any questions. But over to the main analysis. So I'll quickly step through this analysis and show you some of the things in action here. So the first thing is to load the pre-processed data and take a look at what the data looks like. So let me just clear all the outputs from this live script, so I can start from scratch and go back to the live editor tab. I can click on run section or run in advance and run to end in order to go through different sections of the live script. So if let me just do run in advance, so I can load the pre-processed data into MATLAB's workspace, and you can see this is what the data looks like. So we have time information. It's a timetable with a time information as the first column. Then we have the state, year, event type, damage information, and so on. So once I have the data, the first thing I actually do here is to split the time information into year, month, and date, because this is temporal data, but the actual amount of damage that a weather event can cause will depend on a lot of factors. It will depend on when it is happening in the year. It will depend on when it is happening during the time of the day, and so on. So when I'm developing the mathematical model, I'm going to take a look at time information in that sense. So which is what I'm doing here, is to split up the time into those three components. Once I have done that, in order to focus on the most common events, I'm going to remove any events which have occurred for less than 200 times in the last 15 or 16 years or so. So you can focus the model a little bit, and we can see that the most commonly occurring events have been thunderstorms and floods and hail and wind and tornadoes and so on. At this point, I'll take a quick sidebar here and talk a little bit about exactly how I'm doing this subsetting of data, because this is one of the very important and very useful features in MATLAB called logical indexing. So in case you're not familiar, logical indexing allows you to subset data from data of any dimension, and it's really fast. To give you an idea about how it works, let's say I have a variable x, which is numbers 1 through 10 in a random order, and if I wanted to subset, or I wanted to select all the values which are less than 8. In standard programming language, you would have to write a for loop or a double for loop or a triple for loop depending on the dimension of the data to do that subsetting. In MATLAB, it's a single line of code, and I'll show it to you in 2 lines. So I'll first find the location where that condition holds true. So if I write that line of code, LOC is equal to x less than 8, I'll get a logical array with zeros and ones, with ones where the condition is true and zeros where the condition is false. And now I can use this logical array LOC to index into the original variable x. So this is logical indexing in MATLAB. I can combine different conditions as well. I can say y is equal to x of x less than 8 and x greater than 4, for example. This, and you can see the results 6, 7, and 5. So this makes subsetting data and processing data very fast. And as you can see, I showed you an example with numerical matrix, but it also works for categorical arrays and time arrays and so on. So with that aside, so coming back to our main application here, so we subsetted the data, and now we are ready to actually start developing the mathematical model. But before I get into the mathematical model, I want to partition the data into a test and training set, so that we have some of course, we have some test data that we can test the model on. Plus, it also avoids situations like overfitting and so on. So let me just do the partitioning, and for that I'm using the cv partition command. And actually, this will return a logical arrays cv.training and cv.test that I can use for subsetting the data as well. So once the data has been partitioned, now you can get started with developing the regression model. Now, the different approaches you can take at this point of time to develop your model. If you prefer more like programming or code-based workflow, you can explore the documentation in MATLAB, or maybe the function browser here, and you can start searching for functions that can help you develop, like say, like an example of fitting for mathematical fitting. So depending on the toolboxes you have installed on your in your MATLAB installation, this tool will give you suggestions on what functions you can use. You can get some help on that as well, on how to call a function. If you want more help on MATLAB or for this particular function, just click on more help, which is going to open up the help documentation, which is one of the most powerful yet very underused capability, I have to say. Here you can find details on how to call a particular function. You'll find details on what do the input parameters mean. You can see details on how to actually use them. You can see examples that you can run right out of the documentation page itself. Also, if the functions include algorithms, you'll see full description of the algorithms and references as well at the bottom of the page. Another thing which I really like is the section called C also, which talks about some of the other things you can explore. These things could be information like domain information. It could be links to other functions that could be used, and also sometimes apps that you could use to do the same thing interactively. So apps, in case you're not familiar, are as I mentioned, interactive applications in MATLAB that you can access through the apps tab. And these are part of different toolboxes, or you can create your own apps as well. And these apps actually bring out the most commonly used functionalities of MATLAB in a nice interactive window, where you can so you can get started doing your work and exploring your data and your workflow very easily. So we provide a lot of different types of apps. We have lots of apps for machine and deep learning. For example, classification learner, deep network designer. This is a new app that came out recently, which you can interactively design your deep learning networks. We have the Regression Learner App, which I'm going to use in a few minutes. We have apps for control system and analysis, automated driving, apps for signal processing and communication, image processing, computer vision, and so on. We have lots of different types of apps. So I'll encourage you to explore these. So for this particular application, I'm going to use a Regression Learner App, and I'm going to interactively develop a mathematical model that can be used for prediction purposes. Okay, so the app, so this is what the Regression Learner App looks like. Easy to use app. You go from left to right, top to down. We start by creating a new session, and I already have data in the workspace, so I'm going to start with I'm going to choose a from workspace option, and all the data that we are working with is actually in this variable called data test actually. No, sorry, data train. And now the next step is to select the response variable, which in our case is total damage that has been caused. And I can, in the next section, I can choose the predictors. So in this case, I'm going to choose the state, the weather category or the event category, the duration, and the year, month, and day. of when the event happened. So so this is the kind of model that I have selected for this particular demo, but you are welcome to explore other models and other predictors as well. But I just wanted to show you how you can develop a model like this. So with that, I'm going to I'm not going to change anything else in the app, but if you want, you can do that. You can even do another layer of partitioning of data for testing and validation, but I'll just keep the default ones here. I'll start the session. Now, once the session starts, you see a lot more things become enabled, and the Regression Learner app now gives me more options. Like I can do a further round of feature selection. I can enable PCA. I can look at this drop-down menu and select different types of regression models that I can fit. You can see that we're already providing a lot of different types of models. And the point here is that you can quickly try out different models and see which one will work for your application, or at least get you started in the right direction. And then there are a few other options here. You can do some advanced tuning of the model that you select in terms of, and then all you have to do is click on the train button to start the training based on the training data. There's one more button here called Use Parallel. So if you, which is very useful if you want to speed up your training process. So I will actually take advantage of that. So a quick aside here on how to use parallel processing, or how to do parallel processing in MATLAB. So so there are two products that we have that support parallel and distributed computing in MATLAB. One of them is called Parallel Computing Toolbox. The other one is MATLAB Distributed Computing Server. Parallel Computing Toolbox allows you to open up what we call worker sessions of MATLAB. So you have a client session of MATLAB, which is the MATLAB desktop that you're looking at, and then you can open a worker sessions of MATLAB in the background, which will help you parallelize and distribute the work and speed things up. So to show you how actually you can open up those workers, there are different ways of doing that. You can go to the bottom left of the screen, and if you have access to Parallel Computing Toolbox, you can just say Start Parallel Pool, and it will start a pool of workers for you. Or we can take advantage of commands as well. If you remember, we saw the parpool command in the script for preprocessing data. So I will show you how you can use that. So I'm going to open up a pool of 2 workers of MATLAB on my local machine, so that I can use those for speeding up the fitting process. And let me launch Activity Monitor. So you can see, I can see 3 MATLAB sessions here. So the one with the MATLAB logo next to it is actually the MATLAB desktop that I'm working on right now, and the other 2 are the workers that are launching. So with the help of Parallel Computing Toolbox, you can launch workers on a local machine to speed things up, and you can also take advantage of any connected GPUs for speeding up the processing. With the help of MATLAB Distributed Computing Server product, you can launch these workers on a cluster, which could be just a bunch of machines connected sitting under your table, or it could be a supercomputing cluster environment like WestGrid, or it could be cloud computing environments as well. So coming back to application here, so we have a pool of 2 workers available. Now, if I go back to the app, in this case, I will select. Maybe I'll just select all quick to train models and hit the train button. You can see 4 models are being trained. A linear regression model, and then 3 different types of decision trees. And you can see, since I have workers open, the training is happening in parallel for the different models. And as the training completes, we can see the root mean square error measure showing up for the different models, and a coarse decision tree seems to have the lowest RMSE. I mean, so if you look at the app, you can see a lot of other windows here. So you can see the response plots. You can look at predicted versus actual plots, residual plots. It's a way of the different ways in which you can explore the mathematical model that you just fit. And on the bottom left-hand side, you can see the different measures of how the model is performing, which you could use to compare different fits, or you could come up with your own measures as well. Now, once you have created a model like this, there are a couple of directions in which you can go from here. So you can click on the export model button, and you can either export the model or a compact model, or you can generate MATLAB code to automate the process for fitting a model like this. So I'll show you 2 of these. So if I generate code, can get a MATLAB script like this, which gives you full details of how this model was fit and all the selections you made. So which is a good starting point for an analysis, because now at least if you have the script, and you can fine tune this to get a better model of your choice. I will get out of that one, and then if I go back and click on export compact model, that will actually put the model as an object in the MATLAB workspace, so that I can use it right away for prediction purposes. So if I do that, you'll see trained model is the model that shows in the workspace, and we change the window size a little bit, and you'll also see this line of this message being displayed in the MATLAB command prompt, which shows you actually how to use that model for prediction purposes with the rest of the data that you have. So I'm actually going to load a model that I was working with earlier, and in order to do the prediction and fitting, I use the same command, train model.predict function, and then give it the test data. And once I have prediction coming from the model, I can compare that to the actual observations that I have to get a sense of how well the model is performing. As I mentioned, there are different ways in which you can do that. You can develop some metrics of your own. I'm just looking at the histogram of the errors to see what the model performance looks like. And you can see that most of the error is actually quite small, but some of the errors can be quite large as well, which probably correspond to errors with large events like hurricanes, which are very disruptive. Now that I have this whole thing set up, I have actually been able to automate the process of bringing data into MATLAB, processing the data, cleaning it up for fitting purposes. I have done some quick exploratory analysis, and I've also come up with a mathematical model that can be used for prediction purposes. So from here, if I want to say explore what the event damage might look like, I just have to specify in a few lines of code, okay, what happens if a tornado hits Massachusetts, which is 1 day long, and if it hits today, for example. And I can get a quick sense of how much cost it would incur. So that's one way of using this mathematical model. The other way of using the mathematical model would be to maybe create an application, an interactive application around it. So that's where App Designer comes in. So App Designer is our tool for designing interactive applications like these. Once you have designed an application like this, you can take advantage of some of the products like MATLAB compiler and compiler SDK to deploy those on the web as well. We have a few minutes, so I'll take maybe 2 minutes to quickly show you how to create an interactive app in MATLAB, and then I'm going to start wrapping up today's session. But I will point out that everything that I'm talking about, all the tools and capabilities I'm talking about, we have tons of information on those available on our website. So feel free to explore those, and also let me know if you have any questions. So to create an app in MATLAB, you can go to the Home tab and then say New App. Now, I'm not going to show you how to create a full-fledged, complicated, or advanced application that I'm using, but let me show you. I'm going to create an app which can create a 3D plot like this with the click of a button on the app itself. So when I clicked on, when I said New App, it launched the App Designer window, and let me scale this a little bit. So on the left-hand side, we have different types of interactive controls that you can include on the app. We have tables and buttons and spinners and panels and different types of instrumentation and so on. In the middle, we have a blank canvas where you can include those components, and then we have a component browser where you can play with the properties and then configure the apps or components. So in this case, if I want to create an app to plot a 3D plot, I'll throw in an axis here, and I will throw in a button here, which will allow me to interact with the app. I can double click on the button and change the name, say plot peaks. I could also do it from here. And let me go ahead and save this. So I saved it as the first app. And at this point of time, I can actually just click on the run button, and the app is going to run. But it doesn't do too much right now. So we actually need to program the behavior of this this control. Now, if you go back to the App Designer, we'll see there's a design view and there's a code view. So if I click on the code view, that's where I can see the code that goes on behind the app to get it to create it and so on. So what I will do is, in order to actually program this control, I'm going to right click on it and add a button pushed function callback. As soon as I do that, a new function appears here where I can type custom MATLAB code that I might have written and then change the behavior of that control. So in this case, I just start by typing in what I actually want to do, which is I want to plot the peaks, create a surface plot. As soon as I do that, this small warning label shows up. And if I click on it, it says specify a UI axis handler as a first argument, which basically means I need to specify where the plot is actually going to show up. So if you look at the component browser, you'll see we actually have a UI axis component, which is called app.ui axis. So if I put that in, app.ui axis as the first input to the surf command, and then go ahead and save it and run it. Now if I click on the plot peaks button now, I see the plot. So this is how you can quickly create interactive applications in MATLAB to make your workflow and your analysis easier to use and easier to share with other people. In terms of sharing, you can actually go to the apps tab in MATLAB, and if you look at these buttons like package app and install app, these allow you to package up your app for easy sharing as well. So with that, let's go back to our slides, and I just wanted to wrap it up. So just a recap of what we saw. We got data from an Excel sheet into MATLAB, but that's just one way of bringing data into MATLAB. MATLAB supports a lot of different types of databases and web services and IoT platforms that you can bring data in. Once you bring the data in, we have developed a lot of new capabilities that allow you to quickly clean up and pre-process the data with really high-level functions like, for example, here, smooth data, fill missing, and so on. In terms of developing your predictive models, doing the actual analysis, we have tons of capabilities available in the areas of machine learning and deep learning, and we have to try to make it as easy to use as possible by creating all these interactive applications that allow you to do your work interactively, and then you can automatically generate models or code that you can use for automation purposes. In terms of scaling things up, I talked at a very high level about this, but in terms of working with large amount of data, there is only minimal amount of changes that you need to make to your code in order to process whether it's one file or whether it's 100 files. So take advantage of advanced constructs like data stores and tall arrays to scale up your computation. And on similar lines, in terms of actually accessing data itself, it is very easy to access data from different sources. For example, if you wanted to access data from a local machine, this would be the code to create, say, an image data store. But if you're getting data from Amazon Web Services or Hadoop cluster and so on, all you need to do is just change a few lines of code, and you can start working with large data. And we have a pretty solid support for Hadoop clusters and Spark running on them, and we have capabilities for monitoring jobs and so on. So we have a solid infrastructure to support these large data workflows. In terms of scaling up, the other kind of dimension in scaling up is parallel and distributed computing. We spoke a little bit about it. That the tools we have are Parallel Computing Toolbox and MATLAB Distributed Computing Server, which allow you to take advantage of multi-core machines, single and multiple GPU machines, clusters, cloud clusters, and so on. If you have any questions, again, please check out our website or let us know. In terms of sharing the work, once you have developed your application or your workflow, we have different ways of doing that for integration with enterprise applications, with different types of data analytics dashboards, and of course devices, embedded devices, and low cost and or high-end devices as well as IoT workflows. And you can even integrate with production systems. We saw an example of how you can create apps in MATLAB using App Designer, and the same app can easily be deployed to be run as a web application from a web page as well. And in terms of other ways of sharing your work, we saw a few options. We saw the live editor in MATLAB, so live script in MATLAB can actually be saved in different formats. If you want to share your work as reports, could be saved as PDF, HTML, or LaTeX documents. I also want to point out that we have support for standard source control approaches as well through GitHub and SVN if you want to share your work with other people in the community. So with that, I'm going to round it up with talking a little bit about access to Mathworks resources for you. So I've highlighted 3 or 4 pages here which talks about the MATLAB resources that are available to you and the resources available on the 3 main clusters you have, Cedar, Graham, and Niagara. I can bring up those links, and Alex, would you like to talk a little bit more about these?
Well, I'll just mention that you use MATLAB on Compute Canada classes, so we have Cedar and Graham and Niagara, and their MATLAB is available as part of the standard soft stack. So there are different versions of MATLAB. If you type on class, type module available, that will show all the available modules, and then you can load the module that you want to use. And if you go to the web page that you just showed, so the one that ends with the MATLAB in the documentation wiki, it shows you, gives you licensing information. So on Cedar, you can actually use MATLAB without a license. We already have a license on Cedar. And on other systems, you have to bring your own license, or you can run a compiled MATLAB application. So the web page describes everything.
Cool. Thank you very much, Alex.